What is chemical bonding? Chemical bonding is the process by which elements combine to form a compound. And a chemical bond is the electrostatic attractive forces between atoms strong enough for the atoms to act as a single unit. This attraction is created by the transferring or sharing of electrons. Now remember, in past lessons we've talked about electrons being the most important thing that we wanted to learn about the atomic model. And the reason we wanted to know about electrons is that it's electrons that determine the valence shells, and it's the electrons that determine the chemical bonding. And how elements come together and bond and form compounds is all dealing with the electron. We need to know about the electrons' ability to attract each other, and it's this transferring or sharing of electrons that's going to make the difference. And usually this involves the valence electrons. Two major chemical bonds. There's the ionic bond and the covalent bond. Those are the two major chemical bonds, and we need to learn about them. So the ionic bonds are created by the transferring of electrons. One atom gives up its electron to the other atom. Boom. And usually it's between a metal and a non-metal, and they create ionic compounds. Example, there's sodium and chlorine, and you'll notice here that sodium wants to lose and chlorine wants to gain. That's perfect. So sodium is going to give up its electron, and so the electron is transferred to chlorine, and when that happens we create two ions. As soon as the sodium gave up its electron, it got a positive charge, and chlorine accepted that transfer, and chlorine got a negative charge. And what happens to opposite charges? They attract. And so now we have that strong ionic bond created by the attraction between sodium ion and the chlorine ion. Covalent bonds are created by the sharing of electrons. Now, it's not so much a transfer of electrons, but a sharing of the electrons between two atoms. It's between a nonmetal and a nonmetal, and of course they create covalent compounds. Here's an example. We have some hydrogen and some oxygen. Now notice oxygen wants two electrons, and so we had to have two hydrogens. But by sharing electrons, that gives hydrogen its duet, and it gives oxygen its octet. So everybody's happy. Okay, now let's look at some examples here. What bond will form? Sodium and iodine together. So what bond is that? Hopefully you said ionic. Hydrogen and oxygen coming together. We kind of already did this one, and it's covalent. Here's a lithium and fluorine. When they come together, ionic. How about carbon and neon? Neither. Why? Well, there's no bond because neon is a noble gas. The octet's full. It doesn't want a bond. It doesn't need electrons. Doesn't want to give up electrons. Then we have sulfur and fluorine, covalent, and arsenic and chlorine, covalent and somewhat ionic. That's a semi-metal, and chlorine. Chlorine is very electronegative, and so I would say it's probably mostly or predominantly covalent. But you're going to see some ionic property in it because arsenic being a semi-metal and can act like a metal or a non-metal. So on that one, a little bit tougher, but still doable. And you can check that with electronegativities and determine whether or not you want to call it covalent or ionic. Note, ionic and covalent represent extremes. Most bonds are somewhere in between, where they're somewhat ionic and somewhat covalent. And what we look for is it mostly covalent or is it mostly ionic? And a lot of that can be determined by their electronegativities. You know, ionic is a metal and a non-metal, and covalent is a non-metal and a non-metal. It's a good rule of thumb to help you determine the bonds that you're looking at. Let's look at compound characteristics. Ionic compounds are between a metal and a non-metal, have high melting points, they have high boiling points, are crystalline solids. As far as I know, they're all crystalline solids. The ionic bond is so strong that they're all crystalline solids. are good conductors of electricity, and most are soluble in water. Water, being very polar, attracts ionic compounds, and most ionic compounds dissolve in water. Covalent compounds are between a nonmetal and a nonmetal, have low melting points, have high boiling points, can be gas, liquid, or solid, depending on what's bonding and how strong that attraction is going to be, are poor conductors of electricity, and as a whole, most are not soluble in water. Even though some covalent compounds are soluble in water, water is very polar. Remember, water is the universal solvent, and because water is polar, which we'll be talking about in a later lesson, it can dissolve more things than any other substance. But still, we consider most covalent compounds to be not soluble, especially your organic covalent compounds.